Okie doke. Let's see. We have started the webinar and several people are already here. Good morning. Good morning. Good morning. Ooh, lots of people. Welcome. It is a couple minutes after 10. So let's get this started. I'm Katie at the Lighting Design Lab at Seattle City Light. Welcome to the first in a series we're doing with Duane on the 2021 both Seattle and Washington commercial energy codes. We're not going into resi. Um, we're doing one a month, so this is the first one. We'll end in May. Um, and I'm just getting the second one up open for registration. They'll be open later. Just put them on your calendars. And Duane has Nick from NBBJ. He was on a couple years ago too, um, to give you the practical side of how the code works and some ideas about how to implement it. I almost said deal with it. We don't want to say deal with it. Um, just a couple housekeeping items before we get started in earnest. We're going to have a little Slido poll at the beginning. Just really quick, get your phone out, scan that QR code, or open up a different browser tab and go to slido.com. The little numbers are there. I'm going to show this, or this info is going to be on the Slido when the Slido poll actually comes. So don't worry if you don't get all the numbers right now. But just real quick, if you have not taken a webinar with Seattle City Light before, we do these Slido polls just to kind of get a sense of who we're talking to today. And this one's a type in your answer. Who are you? As in what's your job, not your hopes and dreams and wishes. Um, the Slido information is right there on the left-hand side. Good, thank you. Designer, architect, energy consultant, mechanical engineer. We had about 190 people registered for today. So we're going to have a whole bunch of answers, I assume. Lots of architects. This is one of those where, the more times a phrase or word shows up, the bigger the thing is. So we got lots of architects. A very specific project advisor dash energy management. You might be the only one that does that answer. Great. I'm going to go to the next question and give Slido a second to advance. And then where kind of do you do your work? Are you in the Seattle area, more of like Greater Washington, or are you even outside of Washington? I saw a couple of folks from even the Midwest came to learn about our codes. Alrighty, cool, but mostly local. I'm gonna go to the next question. And that is the last one. It's another type your own answer. So what are you hoping to learn today? Why are you here? Just the general news. I mean, yeah, everything. Everything is a big ask. So Duane, I hope you're ready to talk fast. Um, yeah, this code just was, the Seattle one anyway, was just implemented in November. Is that right, Duane, or October? Yeah, but it's been being bantied about for a while. And Carrie, I see you have your hand up. We don't allow you guys to come off mic. I'll tell you that in a second. So I'm gonna go. Oh, sounded intriguing. Ooh, this sounded intriguing. I like that answer. I'm gonna go to the next slide, which is actually going to tell you what I just told Carrie. You guys are not allowed to talk, but there is find the questions. is a little question mark somewhere on your screen, and you'll be able to type in. Oh, it advanced one extra. Let me go back. Type in your question to us at any time. I'll interrupt Duane if it's really timely. Otherwise, we're going to save the existential philosophy questions towards the end, where they can get really into the nitty gritty. There's a chat function too, but it's disabled. So don't try sending stuff in that, it won't work. The webinar is being recorded. All of the dumb stuff I just said is on record, and will be available on our website within about a week. I think the codes recordings are the ones that are most reliably visited throughout the year. People go back and see little bits about what you guys came to tell us. So just know that all the stuff you say gets revisited.
Katie,
And
Katie, I,
um,
Katie,
oh
I've got
yeah,
another second screen going, and I don't see a little question mark on it.
you don't? You have the God permissions.
No, no, I mean on
Um,
just a viewer screen. So maybe there's some further clarification on how they can ask a question. There's a chat button
oh
up on the top,
Right
and
yeah,
to
but
the
you
right
don't.
of the
there,
chat,
okay,
question
I
mark
see
inside of a box.
question mark inside of a box at the very top towards the right.
Yep,
You got it.
Okay,
Yep.
that's it.
Charlie found it. Charlie wins the prize. He's already asked a question. What are the topics of the other upcoming webinars? Charlie, I'll tell you in a minute. I don't want to take too much time because this is a big topic. A lot of you already know who the Line Design Lab is. I'm just going to leave this slide for you to peruse at a later time when you get the slide deck. Um, and oh, it skipped again. Well, I hope you don't have this problem, Duane. Here are, it hid my slide. Mm.
it's
The
censoring me,
most
Katie.
important slide. Um, Let me try again. Nope.
I thought you had
Weird.
the topics in your deck, Dwayne. Am I future
I,
topics
I'm
at the
gonna
end?
I'm gonna have the future topics at a slide at the very end.
Great. I don't know why it's suddenly hiding this slide. So we'll just let Duane do his thing. And thank you, Duane and Nick, for being here. I'm going to go off camera, off mute. I'm going to be in the background lurking and seeing your questions. Carrie, yes, the session is recorded. It's being recorded right now. And Duane, go ahead and share your screen.
You
Thanks,
see
Katie.
that now?
Yep.
Are we good? Okay. Um,
Excellent.
we're dealing with some software here, so anyway, this is our screen for the day. Thank you all for showing up, and you'll see that if you were here for a similar presentation a year ago, uh, a lot is the same, and some things changed due to a big procedural process that happened in the city and the state over the past year. So whatever notes you took last time, toss them out, start over. Um, uh, this is a cooperative effort of a couple departments in the city, and today with NBBJ giving us Nick McDaniel. I've known Nick for a long time, and I just wanted him to interrupt periodically through this presentation with the actual boots on the ground reality of trying to get stuff built. Um, so I'll talk about the rules, and then he can be the guy in the white hat that comes to save you all, I guess. So just a little nomenclature to start. That in 2021, the IECC was published, called the 2021 IECC. Then uh, a couple years later, the state one got out, and then after that, the city one got out. We're calling them all the 2021s, even though they are uh, being issued years later. There are other states that are using like the 2009. So we're not that far off. But anything that if you applied for permit in Seattle uh, before November 15th, then you can be on the 2018 code still. If it was a multi-phase permit, that means it's the package that contains the above ground structural is what determines where you're are on that calendar. And one little thing is that low-rise multifamily is now following commercial building rules. So I don't think anybody's building a low-rise multifamily in Seattle anymore, given land costs, but it could happen. Uh, the envelope follows a fairly reasonable sort of organizational scheme. So as we go through, you'll see that there's kind of these four major themes that we're up against, and so we will not go through them necessarily in order. We'll go through them in some other kind of order here. And if we were all in a room together, I'd have you raise hands to show how many are sick of seeing this particular slide after me using it for the last several years. But we're still mandated by state and Seattle legislation to make progress every code cycle. And so unlike other states where it's the argument is whether to do anything at all, here is, yeah, we're doing something. What's the smartest, most economical way to get there is what we're after. If you see something and you have a better idea about a more economical way to get to the same results, we want to hear you. Please, please, please call me up and show me the way, because the collective brain power on this call is very large, and you've come up with great solutions that seem to work and seem to be economical. Those would be better to get in the code than whatever else we might just come up with internally. And so I still have these same four goals we've had for the last couple of code cycles. And this is the number one. The building envelope is not going to change for 50, 80 years, something like that. And it's going to be just what it is. We have high rises downtown with their original single glazed curtain wall from 1962 or whatever, and they're not changing anytime soon. So if we're going to get to this 2050 goal we have about being carbon neutral city, which requires tremendous energy use reduction as well as decarbonization, then we got to be building envelopes now that can support that. Building envelopes do two different things. One is separating your nice conditioned indoor air from the outdoor air so that people can stay comfy. It's one of the reasons we have buildings to start with. And the other is connection to the outdoors, because it's just good for us as animals to have that connection. So there are a couple of extremes, but the brick building does a tremendous job of energy conservation. The solar gain is very low. The thermal mass is terrific. Not a lot of transitions between materials. So you could run a very efficient building there. Philip Johnson's house there in Connecticut, I'd love to see his gas bills, but does a great job of connection, maybe a little lacking on the separation side. So we're going to have to keep wrestling with this between the connection we want architecturally and sort of spiritually versus the efficiency we want by separation. If you want to not be invited to dinner parties, then be somebody who talks about envelope performance, because it's about as dull a topic as you could get. Maybe water heating is down with the same level, but the thing is that you get this done right at the beginning, and it pretty much just stays that way forever. You get it done wrong, and that'll stay that way forever as well. And if you do it beautifully, no one will ever know that you did it beautifully because it's all hidden. It's not like solar panels on your roof or something glitzy like that. But more than the opaque envelope, it's glazing. We'll talk a lot about that here. The heat loss here on all our cloudy days and uh, uh, cold nights, and the solar gain, the unwanted solar gain we get in the warmer months are big energy users, and we gotta be able to connect. So one or the other is going to work for you. Uh, there's also not only that general heat loss through the glass, but there's just conduction around through the whole framing assembly and the perimeter. There's thermal bridges through the insulation. Air leakage, it's a real popular spot for air leakage is around the framing of your glazing. On the good side, on a day like this where we've got sun coming in and it's cold out, that actually works to your benefit. So it's not all bad for energy use, but it's just anybody who had to go through architecture school passed a test where they identified that model on the left, and yet this picture I took in Toronto a couple years ago, it's like we're still there. There's this fascination. Now it's been like 3 or 4 generations of architecture professors just drooling over this idea that it's just all glass, floor to floor, wall to wall, every place. And the great thing is that architects still think that's original. But maybe, oh, and here we have the Portland building. Maybe
So
Nick has something to say about that.
yeah, so Duane and I have been fighting about this for about 20 years, right? But you know, I think the other side of the coin, right, is I'm a poor schlep that sits in an office building for 10 hours a day being an architect, right? And looks out those windows and relies on them to get my connection to nature. And so I think the flip side of the question is when do you go too far? What's the right amount of glazing? And are there any technologies that could maybe allow us to have our cake and eat it too? So have the great, have more glass and have energy savings. So if you hit the next one, Duane. Um, and the biggest problem with that I mentioned on the last slide is just, that right now the glass is about 7 times the conductance of the solid wall, which is really something. And that's where the problem hits. So a couple products we've been seeing, caveat, caveat, caveat. I have not used these on a building yet. Building construction is conservative for a reason, right? There's a lot of things that can and do go wrong, but one really hot product we're seeing is vacuum insulated glazing. Um, and basically, if you can see over to the right, vacuum insulated glazing is showing about the same U value as a solid wall. They're claiming. Now that's just for the unit. Obviously, you get the frame and the glass and other things that start to happen that would move that up. But what this basically is that they have a very small, very thin sheet of glass they insert in your IGU, and then they have BBs, for lack of a better word, spaced, every few inches that hold that glass away from your thicker pane of glass, and then they vacuum insulate it, so they suck the air out of it, and that provides a very great thermal break. Like I was saying, I don't know anyone who's used this on a project, and I have not used it on a project yet, so remains to be seen. Do you want to flip to the next one? The second thing that Duane mentioned is solar gain. And so one of the other really effective strategies we're seeing for solar gain is the electrochromic glass. So glass that basically you can dial the amount of shading or the direct solar heat gain on the glass. But some things to know about this: we are using this and have it going up on a couple projects that I'm aware of, though they haven't opened yet. So I haven't had the chance to go in and really kick the tires. But one thing to know is a couple of the places I've gone to see and experience this in person, the glass has had the light coming through the glass has had a slightly bluish tint, which can be a little disturbing for people. The other thing to know is that if it darkens differently, on your building. You can have a very patchy, strange looking building from the outside. And that also, when it really goes fully dark, it looks like 80s kind of Darth Vader glass. It goes very dark from the outside. So there's a few different products. Virecon's got one, Sage Glass. There's a bunch of different ones. Once again, the jury, this hasn't stood the test of time yet. It's a relatively new technology, and would love to hear what people think about it.
And if you want to amuse yourself when you're at one of these conferences that has an exhibit hall, go up to the salespeople for this or the vacuum glass and ask them, so how much does this cost per square foot? And,
Right.
and it's amazing. They have these beautiful, really entertaining 10-minute spiels that they will give you without telling you how much it costs. I
Right.
was at another conference a while ago where somebody was presenting a building they'd done in this, and I said, "Oh, finally, we have somebody who's not the manufacturer. How much did it cost?" He said, "Well, uh, we have a non-disclosure agreement." So
Right.
there's a real
Right.
good reason that you don't see
Right.
much of this. But like much of technology, it's coming along. Probably some grad student in Taiwan right this very minute is about to publish some invention that's going to lower the price, but we'll have to wait for that. All right, back to the nitty gritty. The U factors for fenestration got tightened up a little bit this time. The uh, and note that when you look at these tables, uh, there's they, they actually turn around. They start by saying Class AW windows, and people get kind of hung up there. But um, it, this first category mostly applies to site-built stuff: curtain wall, storefront, ribbon windows, all that. Class AW is a window that you use when you have a very high wind uh, situation, and that's 0.34 now, and the punched windows that just come on a truck all completed and get put in an opening in the wall, those except for the AW windows are 0.26.
And these are really doable. I think that's an important thing to say. If a curtain wall manufacturer tells you that they can't do this, it should be doable now, right?
Yeah,
Would be my message. Right.
find a different curtain wall manufacturer. Yeah. Um,
Right.
we had a whole bunch of fancy stuff in our presentation last year about how we were going to like start requiring much higher performance from a fraction of your glazing, and that disappeared in the final round here. So it's same as the state code. You got a 30% basic thing, and then if you want to go higher um, uh, to 40%, you can do that with in a couple of ways, but one of them is the high performance glazing, and that's got a little better U values uh, uh, than the typical. Nick.
So the other way to get there is with the daylight credit. And my message on the daylight credit is that it has gotten progressively more and more difficult to get, as Duane has tightened things up over the years here. And so, the first time I used it, we breezed through. It was really easy. The next project I did, was a office tower that was designed for daylight. So we designed it in from the beginning. It was very slim. It had very small floor plates. We barely made it through. My last project was a two-story project with just a ton of skylights, very thin bar office. It was actually a bus charging yard, or bus charging shop and office. Even with that, I barely made it through. So it's getting more and more difficult. This is very hard to do on a high rise, would be my
Yeah, you got
message.
to have half of your
Right.
floor area in a daylight zone, which is very difficult to do with your vertical glazing. So like Nick
Yep.
said, a low rise with a bunch of skylight, that that should go. You can have pretty small
Hmm.
skylights, and it's and to light up large areas of floor if you've got a high enough ceiling. Um, we in Seattle are one of the only places in the country that really is serious about that you have to meet NFRC standards, and especially if you're doing any kind of site built glazing, you have to get what's called a label certificate, and and that the the manufacturers tend to want to like send that out like 6 months after the job is finished. But no, the reason we want the label certificate is so that the inspector can look at it and make sure that the actual U values of your of what really got extruded and built for your curtain wall is uh, at least as good as what was shown on the permit documents, which means that you got to have that when the before that first stick goes up on the wall. Um, you can on the way into it, uh, we do allow what's called a CMA bid report. That's another NFRC term, but it's reasonably inexpensive, much less expensive than actually doing a real simulation, which requires a specific manufacturer. So we just note that we have this tip 403 that has pages and pages of stuff about this. I'd suggest you go there. Nick, you,
So a really important thing to know is first the test size is going to be different than your actual size, right? So it's the 79 by 79 inch unit with one vertical mullion, and that performs usually a lot worse than your typical curtain wall with really large expanses of glass and very little aluminum. So be aware, right, that the test is probably going to be different than your U value for your skin, and you need to use the more conservative number. Can you go to the next one there, Duane? And then one other thing to really think about when you're looking at this is one of the things I discovered on one of my more recent jobs is that we've always done 5 foot curtain wall units, 5 foot, 5 foot, 5 foot. There in this job, it turned out there was just a lot of extra aluminum because we really wanted more of a 7.5 foot spacing on the windows, and we were adding extra sticks. If you imagine, 2/3, an extra third more aluminum sticks. Aluminum is the problem, generally speaking, with conductance through a curtain wall. And so if you can go to a larger unit, we went to a 7.5. They can still fit that in the elevator. They can still take that up. They can still use all their equipment to hang it. We saved actually a good bit of money. So we saved about 5% on the cost of the curtain wall. We saved 15% on the U value of the curtain wall and about 1,100 tons of CO2 in the aluminum. So win-win-win. If you can go to a larger unit, do it. It'll really help you in terms of your carbon.
so you use the standard size unit um, uh, to show that you've got code compliant system going, but these larger units are what you'd use for your UA calc for your whole
Mhm.
building.
Right.
Um, so just to reiterate that if you're not doing site built stuff, uh, if you're buying windows or window assemblies that go into punched openings, like most multifamily would do, um, then you just got to have that sticker on the window. It's got to actually be as good as what you promised when you were doing the plans. And one little side note: there's some default tables in Chapter 3 that you can use if you don't have any kind of NFRC information. Don't ever go there. They're extremely conservative for a reason. And yeah, you uh, it, it it's sometimes it has come up when sometimes people wanted to bring in these windows that were from grandpa's old store back in Cle Elum or whatever and put them in this building, and we can do that, but you have to use the default values for those, and you'll pay for it. NFRC.
Yeah, so the last thing I just wanted to say about NFRC is that I've had more problems with it on more jobs than I can count, right? And what typically happens is, you talk to the sales guys, they give you an NFRC for their system. They say that that's what it's going to be, and then when the actual simulations come in, they don't match, and they're frequently worse. And so a couple times I've had to redesign entire facades because the NFRC did not come in at what we thought it was going to originally. So if you can get that NFRC in hand right away when you start designing your facade, you're going to be in a lot better shape. And I just threw this quick diagram of just a typical building and NFR, calcs for the UA and how much effort that takes. And it takes, a lot of hours to redesign that facade, hundreds of hours, when that NFRC doesn't meet calcs. So get it first, and don't have to redesign it.
Yeah. So pre-design meetings, pre-construction meetings with the general contractor and the specialty contractors and suppliers all there, and make sure that it's in contracts that this is really serious. This is Seattle. You got to do it. Don't don't mess around. Get get these going, and they'll still be complaining, but make
Oh
sure
yeah,
it's
right.
all on record that they have promised to deliver a particular U value.
Right.
Um, just one little pet peeve is that if you see that my little sketch on the left, um, maybe this is why I'm no longer actively an architect, Nick. What do you think? But that you could put all kinds of
Oh, that's good.
insulation in there, but there's a short circuit between the vision glass and the spandrel area that just allows heat to flow from your nice warm inside straight out to the cold outside with almost nothing in the way. There are a couple of manufacturers now that do an extended frame that allows you to have that insulation outside of the structural frame rather than in line with the structural frame, and that solves that problem. Other designers have said that they continue to use the double glazing in the spandrel part of the curtain wall to help prevent that. Um, Although in my mind, that is something that will hit that value engineering buzzsaw and disappear at the last minute. But uh, getting and there's teams of people around the country working on this, but we typically evaluate the opaque part and the vision glass part separately, and as though they're not connected, but there's a real short circuit that's going to get dealt with in the next code cycle or two. Uh, so there's a couple of condensation slides. Nick, you want to take these?
Uh-huh. Yeah, so one of the things that we've started to encounter, as the energy code has gotten tighter and tighter, and the U values we're looking for are better and better, especially with curtain wall. What we've started to do is add more and more insulation behind the curtain wall, in the spandrel zones. And one of the things that we've discovered is that moves the dew point line, basically back into the building farther. And so in a typical curtain wall, your vapor barrier is the foil face at the back of the mullion, um, and that then is inside of the dew point. But one of the things we've discovered is that as you add more insulation behind, which you can see to the right there, on a project, you in turn move that dew point back, and there's some danger of starting to get the dew point into the building itself, i.e. condensation inside your building from warm, moist air from inside. So if you go to the next one, Duane, so on a recent project, we noticed it enough to the, the enough that we actually needed on all the vertical mullions to jog the vapor barrier in 2 inches. So you can see this is a plan detail over to the right, and pretty far along in the project, we discovered that in places where there were higher occupancies, we actually needed to jog that vapor barrier in, which, if you imagine, with thousands of millions, is a really expensive endeavor. So some advice to y'all as you're looking at this. The first one is that the way we caught this is that there was a requirement for the curtain wall manufacturer to run condensation analysis, at several locations, as part of the job. Um, really make sure that's in your specifications. This is really, really important as we move into more and more insulation, is to require those condensation analysis in your specifications. The second is that if you can, hiring somebody, basically a curtain wall consultant to run those analyses for you early in your design is a really good idea for your typical locations, at least. And I'd really advise that if your job can afford it. It might be a lot more expensive further on. If you can convince your owner it's really worth it. The last thing to know is this is not something architects, this is to my fellow architects out there, you should not be trying to simulate this yourself. This is really complex, right? This, affects outside temperature, inside temperature, and occupancy of the space and how much humidity there is in the space. This is hire somebody to do this analysis for you.
Seattle is blessed with several, I count at least 5 very high
Fantastic.
quality
Yes.
envelope consultants that have trained building scientists on staff that actually understand and can visualize all these things and do the computations. A lot of parts of the country do not have that expertise anywhere locally available, but if you talk to your insurer, they will support Nick on this. Like
You
he
do
can
not
talk
want
about it.
condensation inside your building. Yep.
Yeah,
That is
because it's
that is
going
a
to
real
show
thing.
up about 8 years from now,
Yep.
when things finally start
Right.
corroding out. And um,
You get
we
that
have
phone
something in
call.
that, yeah, a
Hmm.
really lousy phone call. We have something in the code here that says that if you're doing energy modeling, uh, you can't any longer use it to make your building envelope substantially worse. This in Washington, you can't make the UA more than 20% worse than prescriptive code would allow, and in Seattle, it's 10%. I've been going for 0, but people like Nick sort of grabbed me by the collar and said, Duane. But that that is really serious because modeling has been um, used almost exclusively to make worse performing buildings because people have been trading this lousy envelope for stuff they were going to do anyway in the building, and so they got kind of a free pass to make the buildings worse, and so we're trying to put an end to that and make it more real. Nick.
So, I mean, I think this is a real time when you ask yourself, is the juice worth the squeeze? So, in other words, if you get 10% savings on your UA calcs, and apologies to energy modelers on the call, but energy modeling is really expensive. And could you take that same money and put it into improving your building, and just do a UA calc, instead of doing the energy modeling? I'd say at 10%, you really start to have to question, whether or not it's worth it. That would be my question, Jill. So something to think about. A lot of work to do the UA. It actually is a lot of work even to provide the information to the energy modeler. And at 10% savings on the UA of the skin, it's questionable.
Just a word about vestibules. We I just put this slide in there because I think it's just kind of sad that you have this opportunity to do something really designy with that interior thing, and I very rarely see a vestibule that looks anything other than like just designed by the manufacturer or something. So come on, architects, you can do better than that. I saw a picture once, and I've never been able to get back to it, that had both sides of the vestibule being divided into these little 1 foot cubes that contained products that were made by firms in the building. I know there's cool stuff, but just require there. You have to have them uh, for the doors that are commonly used by occupants to go in and out of buildings, or in and out of spaces individually, unless they're smaller than 3,000 square feet. The stuff that is just used for bringing in the supplies to the back of the restaurant, or only for emergency egress, or little Starbucks or something like that. The one from the dining room to the outdoor dining area, though we have specific exemptions for those. You don't have to do it. For those swing doors that are next to the revolving doors, you've got to have them because a lot of people just use the swing doors. Note that you can use an air curtain uh, instead of the vestibule, and there's good evidence that those are equally effective.
So this is just a warning to architects especially. The vestibules, we tend to do retail very late in the design process, and it's frequently a different design firm. So there's been real problems in the past with having an undivided space that has one vestibule, and then having an owner go in and find people to take all these different retail spaces and split them up, and then discovering farther down the line that they need vestibules in all those smaller spaces, right? So you really need a note that lets them know loud and clear, really big on the drawings, that really says if you're making a space that's greater than 3,000 square feet, you have to have a vestibule for that space. So this is something to really watch out for. It's going to be a very unhappy owner that sells a retail space and then discovers that he has to put a vestibule in it.
And this is really tough because, a typical building maybe has 10 or 12,000 square feet of ground floor retail
Right.
out there, and when the building opens and there's office tenants or multifamily moving in up above, those are still empty, bare spaces, and nobody knows if it's going to be six little shops or one big restaurant or whatever.
Right.
So
Right.
it might be that you design things so that that the vestibules could be added if they're if they're dividing it into larger spaces, or not. Just uh, just be aware that it's a decision that'll have to be made further on, and like Nick says, you want the owner to know what's going on. Uh, just a little bit about thermal bridging. Uh, Concrete balconies, have been the big bugaboo for ages. So we made these rules that said, okay, you have to account for this heat loss out through there. You can use one of those fancy uh, R10 thermal brakes you can buy that cost, I think it's what is $110 a lineal foot, Nick, something like that for those. Um,
Yeah.
or you could just consider that to be bare, an uninsulated stripe of concrete wall, and somehow do your UA calculation uh, using that. But they that's a Ducati motorcycle uh, radiator on the one side, designed to dissipate heat as effectively as possible. And look at those high rate. Those are brand new. They just opened up, I think, in South Lake Union here under like the 2015 code, I think, with just the same proportions. They're just incredible at getting rid of heat. But when we went into the next code, I did a little tour of balconies around several neighborhoods in Seattle and saw that nobody's doing that anymore. They just swing in those clip-on balconies that you can get. It takes some crane time coordination, or they found other ways to put in balconies that were not cantilevered concrete, and life just went on smoothly. So there's an example of a code change actually making this big difference. I wanted to say also about thermal bridges that we're trying to make sure that where the if you look on the far right there, we'd like the glazing line and the thermal break in the framing system to line up with the main part of the insulation. You can set it back as much as 2 inches in the code, but architects are just always like crazy about this shadow line thing, and so that does make a big space. So if you're not within 2 inches of the glass, then you have to take that area that's in the middle there, and make sure that the rough opening is insulated to at least R3, so you're trying to prevent that from going through.
Mhm. So that's a really expensive endeavor, and part of the reason is that once you jog the water line, so if your sheathing and your window, the back face of your window are not in line, then really what it requires is a lot of three-dimensional flashing, we call it. And so what that means is you have to buy preformed um, flashing for each corner of a window. And so if you have 1,000 windows, that's 4,000 preformed flashings, which can make your owner really unhappy. If you can imagine, they can be quite expensive. So I just threw out an example. This is a project I did a while back, but you can do a lot with metal. And so, you can get a lot of the shadow lines and a lot of the looks that you want out of metal. So in this case, this is the opposite of what Duane's talking about. We wanted the windows to be out flush originally on this project with the brick. But if you imagine this brick, airspace, insulation, and then the water line. And so what we did instead on this project is we framed the windows with the metal surround, got that shadow line, got the look we wanted, but kept the back face of the glass in line with the air barrier, which was really effective.
Cool. I just wanted to mention about here's a mechanical item in the code, but for multifamily, we put in this big exception that said exception to the heat pump rule that says, okay, you could have 750 watts of electric resistance heat per room in your apartment. And it turns out that if you do a good job, or just a competent job of following our local code, then 750 watts or 1,000 for a corner room is fine. A couple of years ago, some people at RDH uh, did a study for me and showed that it's just not a problem for your typical interior unit, that you can have you can get plenty of heat in your space within the 750 watts, which, by the way, we just chose that because that's the smallest size that a lot of manufacturers make units. Um, uh, when you're doing, in this case, a corner area, is that you're pushing it a little closer to your 1,000-watt thing, and you can still do it. It's still uh, it's still possible. So you might end up wanting to do a calculation at that corner to make sure that you're still within bounds, and if necessary, slightly tighten up the U value uh, of your assembly. And it could be that if you still can't do it what you want, get a triple glazed unit for some of those, and that'll cost an extra $1,000 versus an extra 12 or 15,000 for the heat pump. On the other hand, market rate units are typically using heat pump heating anyway because people like the summertime cooling. But certainly for budget apartments or affordable housing, this is something you need to consider. Before I'm going on, Katie, you've been really quiet there. Is there anything that you needed to interrupt?
We have a handful of questions. They're not necessarily, need immediate answers. Do you want to answer any, or do you want to continue?
We'll just continue, but let us know if
Oh,
there's something that helps people understand what's going on here. We're going through a lot of slides and pretty fast.
yep,
Um,
I will.
all right, so PTAX, package terminal air conditioners, or PTHPs, package terminal heat pumps. I'm morally opposed to them. They tend to have lousy efficiencies, and and we have set it up so that you do have to, if you're going to use these anyway, and they meet other code requirements, then uh, you've got to set it up so that uh, we're recognizing that whole 7 square foot area that they take as having a U value about the same as single pane glazing. Okay, so so uh, you have to then go back and make sure that your envelope calc works when you're doing a UA, including that default U factor of 0.50, which is pretty terrible, compared with like 0.56 for uh, a typical wall assembly. So that you should keep in mind. There, another reason they're lousy is that there's that sleeve. It's useful when people come to service the thing, they just pop it out of the sleeve. But when it goes back in the sleeve, it's never going to be as tight. It's going to be a continual air leakage problem in the life of the building, which can cause other issues for you going forward. Yeah. So we have this footnote in there that says that in that wall table, the footnote K is what tells you that you need to do that calculation if you're going to use those through all units. Note that there are, I can't talk about brand names, but there are a couple of excellent pieces of equipment now that instead of going through the wall, they sit entirely inside, and they just have a 6-inch round or 8-inch round vent through to the outside, and so they're a perfectly good heat pump without being a through wall unit, and some of them even provide the necessary ventilation for the space. So check out what is also available there. We in Seattle we had a few special case U factors. Just this is a response to people asking questions about what's how to treat the code. So we've got one for where the slab edge pokes through the wall. That's that thing I showed you about the thermal bridge for a typical balcony. We have a couple others for when you're going from the conditioned space in the apartments or the office building or what retail down into the parking below, that where there's a concrete column connecting there uh, uh, or a wall. You have a particular U value now that's been assigned there. That's a little more realistic, and and if there's a slab that's right above an electric fault, there's no insulation required between that and the conditioned space. Uh, Electric faults tend to keep themselves warm as they are, but it resolved a really difficult set of technical problems. Air barrier testing, we're serious about that here in Seattle uh, and in the state now, and the test standard for both is 0.25 CFM. It used to be 0.40, and you have to pass. And you have to, if you don't pass, you have to keep testing till you do pass. We have, I should say, uh, as far as I can tell, we have never had a building fail where they had hired one of those top several uh, uh, building enclosure consultants in Seattle. Those guys just ride herd on the design team and the construction team and make sure that it all works. But some of the 5/2s have had problems, and it used to be that we didn't make you pass. You just had to do the test. You got to pass now. So you can either test the whole building, or there's something in there in the code now. If you for larger or more complex buildings, that you could test all the stories that have a roof right immediately above them, anything with an entrance or a loading dock, or that's an exposed floor to an unconditioned space below, or a below grade wall, and just 1/4 of the above grade walls. I don't see how this is going to end up being less expensive, but if you got stories about using this workaround, please let me know how it's working out. So there's an alternative to testing a building with all the walls. I should also say that curtain wall buildings in particular uh, virtually always pass. They only have trouble at the entrance and loading dock and maybe the mechanical room at the top. But the curtain wall assemblies themselves are terrific. This kind of we have been allowing this for tall buildings, a variation on this where people would come in 10 stories at a time, and we would say, okay, just test these 2 stories out of your 10, and this is trying to move this forward. But typically, I think for a medium or smaller building, just do the whole thing. Got a few things to talk about here. Nick, do you want to mention just your experience with smoke control?
Yeah, so one of the things just to be aware of is that a lot of the smoke control analysis that they're doing is based on pretty old approaches to building tightness. And so one of the things that we've been running into a little bit is that as the building gets tighter, you need to make sure that your smoke control engineer is aware of that tightness when they do their analysis. Otherwise, when they go to actually physically test, there might be some problems. So make sure your engineer is well aware of that tightness.
Yeah, and if you remember stack effect from school, there's on a cold day like today, the air is moving up through your building, being drawn in through various little openings in the bottom part, and going out through the building envelope or through any opening it can find in the top of the building. If you've been up on the top of one of our high rises downtown on a cold day, you can the air is just roaring up the elevator shaft. If you are building an envelope with this kind of tightness that we're talking about now, that's cutting that down by 3/4 or more.
Yep.
And I have uh, building consultants who said the idea that you need to, we've always said you have to slightly pressurize a building to kind of make sure that if anything, conditioned air is moving out rather than allowing any outdoor air in through the assemblies. That you got down to 0.25 CFM on your envelope. That's under test conditions. Normal leakage, it's like 0.01 CFM that's actually going to be coming through. The the need for the building pressurization is going away, and that's a lot of fan energy for perpetually for your building that you might not have to be using anymore. So along with great envelope consultants, Seattle has a few mechanical consultants that are also like willing to believe their own calculations and do new things. And you should find those mechanical consultants and ask them these questions. Some of the others, well, a lot of you know my attitudes. So uh, you can't test an air barrier by like looking at it, although in many codes around the country that's just what's allowed, uh, because the leakage you can't. There's not like an obvious gap any place you can typically see, but when you got it pressure tested and you got a thermal imaging camera outside, that's pretty screamingly obvious where the leaks are. The the leaks do not come through the materials themselves. They don't come through the assemblies like manufactured windows and like that. They come through the gaps between things where one trade's work stops and the other one starts. Uh, uh, I surveyed uh, general contractors a while ago about where the leakage was happening, because our big high quality general contractors in this area all have envelope gurus on staff now that track this because it's a big liability for them. And so anything, a vented roof of any kind where there's air movement up in there is clearly the worst. Around doors, around range hoods, any kind of penetration through the wall that other trades come up with. Um, Everything electrical shoots roof acid. So you're you're pre-informed about these things. If there's a general who's riding herd on everybody to keep that leakage down, then eventually each of these trades learns to make those leaks go away. Except maybe the vented roof thing, which maybe you should just avoid and put that insulation on the very top of the roof.
I think the
So,
thing Duane said that's super important is just that it's not just so it's important that the leaks for energy, that stops the air leakage, but by making those buildings tighter, it also means that less water will leak in for the buildings, and that's a big benefit. That test is actually our friend. It's a great thing. It really helps to make sure buildings are going to stay watertight for their life.
it's amazing that you can have what looks like a really solid thing and find that when you've
Right.
actually tested a curtain wall assembly or something, that one of those corner details has a little leak in it. If you can find those and fix them in advance, that's great.
It's wonderful.
Um, some uh, Sometimes people are trying to get spaces defined as semi-heated because that way they don't have to do the wall insulation. Just remember that all the windows and the roof and the slab edge and everything else has to be insulated, because we found that so many of these uh, are converted after the fact to fully conditioned spaces, and we making it easier for people. But um, if you have like less than 8 BTUH, which is like a 2.5 watts or something of heating and no cooling, you can call it a semi-heated space. Uh, Everything else is the same. We have an exception built in there now that says that okay, if that heating is being done by heat pumps, which naturally implies cooling, that and you have it set up without any kind of electric resistance backup, a thermostat that only recognizes the heating call, uh, will let you use that, uh, heat it by heat pump.
So this is another one where I just say you want to ask yourself if the juice is worth the squeeze. On a lot of my projects, will have a sprinkling of semi-heated spaces down through the garage, little, little mechanical rooms, little things here and there. They're usually pretty small, and one of the things we've discovered is that the effort to document for the energy code all those semi-heated spaces, why the walls aren't insulated, why, the confusion it kind of causes the reviewers, it's just typically not worth it. It's a little tiny bit of insulation you add, and it's just not, juice is not worth the squeeze. So same thing. I just think, if you have a giant semi-heated space, it might make sense, but boy, for that 10 square feet, you might think twice.
Yeah. Um, just you're talking about a couple
Right.
100 square feet of rigid insulation.
Yeah.
Uh,
Right.
like, yeah,
Right.
it could be way easier. We're going to talk a bit about existing buildings here. Um, just mention that if it's an addition to an existing building, the envelope meets code. I'm not sure if this envelope in the picture meets any kind of code, but it's federal government, so they can do what they want. Uh, Additions do have to follow the C406 credit rules, and you can do that either with the addition alone, or if it works better for you, looking at the whole addition plus existing. And we did finally put in a threshold that says, okay, if you're smaller than 500 square feet, that's not going to require any of those credits. The fenestration, we run into these weird situations. There was a high rise across the street from me downtown that took 3 floors that had been windowless uh, technical spaces and made them into office spaces, and those were getting new windows, which would have pushed them over the edge. Anyway, we're saying, okay, you can have things comply if the addition plus the existing complies, or uh, if if you do a UA calc just for the addition, or or you could do it for the addition and the existing, or you could do modeling for the addition by itself, or modeling for the addition plus existing. So you got several paths you can choose from depending on how it works. Alterations, uh, basically anything's new. If you're replacing a wall or replacing a roof or replacing a window, that new thing is uh, must meet current code. If it's existing and you're not touching it, there's very few situations where you'd be required to change anything. And we have that little list of exceptions, including that if if you've opened up a cavity, you at least got to insulate that cavity, but don't have to completely bring that up to current code, which would have involved continuous insulation and recladding and all that. You don't have to do air leakage testing on an alteration. Yes, on an addition, but not on an alteration, except if it's one of those three things: subalts, or change of space conditioning from unheated to heated, or change of occupancy. Uh, and a change of occupancy is not just any change; it's from something impolite like storage, utility, hazardous, um, to a more polite occupied space, like business or retail or residential. Those and so those three were the city treats somewhat as being new buildings. You have to bring um, those up to code or close to it. But in addition, roof replacements, which are like you're taking the roofing down to the deck or down to the insulation, um, uh, those have to get insulated. And where that's creating problems for you for drainage patterns and stuff on your roof, come talk with us. We have procedures for letting you come up with a design that still drains the water off the roof, but gets it as insulated as we possibly can. And by the way, this is
Uh-oh, Dwayne, you're frozen for
Yeah,
us.
Duane, you're
Nick,
frozen.
is he?
Oh, he just started moving again. You unfroze,
Oh,
Duane,
there
is
you
the
are.
good news. Okay.
it was cold in here, yeah.
Yeah. Um, so so one thing that is really important to just be aware of is substantial alteration, right? Which we refer to as subalt. But anyways, this just from experience is a very gray line with alterations. And the city has an entire CAM 314, that kind of helps you understand if your project might be a substantial alteration. But if you're looking at an alteration to a building, I really recommend meeting with the city early, to try to find out if it's a subalt or not. Because if it is a substantial alteration, there's a bunch of things it triggers that are really costly. And you don't want to be surprised. You don't want your owner surprised by a substantial alteration that comes after you submit your permit, for example. That is very bad, right? You want to know in advance if it's going to be a substantial alteration, what will trigger it. So please meet with the city before you undertake.
And we have, I mean, if you're all familiar with the Husky Stadium uh, expansion that happened
Right.
15 years ago or something, 12 years ago, they were in trying to not be a subalt. It's like, how substantial are you? But it's the idea is that at a certain point of change to a building, we're saying, okay, this is close enough to being a new building, that we're going to take this occasion, since you're doing all this major work anyway, to bring the life safety and seismic and energy up, not all the way to new construction standard, but close. And in this way, over like a 40-year cycle, we get all these buildings improved. there are just 2 people in my department that have the authority to make this call, and so you come in and make your case, and then they will make the call, says yes or no, you are or you are not a subalt, and we will work with you. Fenestration is in an alteration is another interesting area. You can have the new plus the existing just comply with code already. That's great. Or, oh, I said addition. I mean the alteration area only if the code official says okay. You could do a UA calculation for the whole thing, and and we'll let you be 110% more than that. You could do modeling, and we'll let you be 100% better than that. Or you could simply not increase the existing fenestration area. We do allow that you can upgrade, do something to the whole UA of the whole building so that overall energy use is not increased. That's fine. You can do uh, area weighted in averages for the U factors for various kinds of fenestration that are the same type. If you have 4 different kinds of punched openings, those can be area weighted. There's a heat pump. This I'm talking about a change in space conditioning, which you would think is not an envelope issue, but we're saying that if all you're doing that's creating cooling in the space is that you're taking the existing gas or electric resistance heating system and replacing it with a heat pump, which we want you to do, that we will not consider that a change in space conditioning, and thus the envelope would not have to be upgraded in that project. Just a quick mention at the end here that we got the clean building performance standards, right, that are going statewide and are starting to kick in the very near future. And Seattle's building emissions performance standards, it's also starting to kick in. And it may be that especially those buildings that have been around a long time and are maybe your envelope consultant would tell you that aluminum framing system is nearing the end of its life or something. You could end up doing something with envelope. We've seen several manufacturers now that do inserts for curtain wall systems that take a single pane unit and convert it to a double or a triple pane unit. And I spent a lot of time hassling those people, and it turns out there's some testing showing that there hasn't been a condensation problem. So there might be some ways that you can upgrade your building for better comfort inside, and that will also reduce the amount of electricity that's going to be needed as things transition to heat pump systems. If you could maybe get your building converted over to heat pumps without having to increase the city light electrical service, you'd be a hero. So look into what envelope upgrades are going to be required, because an awful lot of the buildings you see in this picture and anywhere in town are going to be are going to need to do some changes to meet these new standards. With that, Nick and I are about done here, except for questions. But wait, please contact us if you got further questions about this. We have more. This is the tentative schedule, but certainly the first 2 coming up are on the way, and we'll see you back there with a different special guest. The slide deck and the recording can be found very soon on at Lighting Design Lab on their website. And with that, are we ready for some questions?
Let's do some questions. All right, very first question. When will the new envelope energy code form for 2021 Seattle Energy Code be available on your website, Duane?
I think you just got frozen, or I just got frozen, or both.
No, she did. Katie did, yeah. Right.
I
Okay,
did. Okay, let's try it again.
yeah.
When will when will the new envelope energy code form for the 2021 Seattle Energy Code be available on the SDCI website?
So this is an ongoing discussion between us and the state and the vendor who does those forms. So we don't have them yet. We've been working around by having people use the state forms that are posted right now, with just some side notes showing how that conforms with Seattle code, and we're working on it. Not there yet.
Okay, then maybe you might not know to the answer to the second part is will the form contain a section for calculating column penetrations?
Um, that's a good question, and I hadn't talked to the vendor about that, but should be. Yeah.
All right. And then Catherine suggests that one slightly lower tech alternative to high performance dynamic glass like electrochromic would be high R glass with operable or automated shading systems. Are you
Mhm.
seeing this being integrated into designs? And is there an easy way to get code credit for these types of systems?
Tell them the bad news, Nick.
So, so uh, we are seeing it some places. It's part of what Dwayne's. We have an automated shading system on our office at NBBJ, and it doesn't work well. I'd say it tends to shut. Like it'll be a cloudy day and nothing, and all the windows blinds will come down and shut. But I think the technology has come a long ways. It's very expensive, and it's expensive to maintain. So we're not seeing it a lot on high rise, but I think it is pretty effective on some low rise applications where it's easier to maintain and doesn't cost quite as much. Do you want to talk about, Dwayne, in terms of the structural heat gain and how that works with automated?
Um, uh, yeah, the idea that I like the idea of external operable shading,
Right,
and if you go to Northern Europe, every new building,
right.
high schools, office towers, hotels, hospitals have, you see the sun come around the corner, and suddenly all these little canopies project out. They have a whole infrastructure in Europe, obviously, to design and maintain these things, which we don't have here. One uh, in the comment, it was mentioned about R value. There's now at least two manufacturers locally that are using what's called a thin triple.
Hmm.
This was developed through Lawrence Berkeley National Labs, and they, in the same byte width that a normal double painted glass comes, there's they use that thin glass that's on your laptop, very thin stuff, in the middle there, creating a triple pane glass with hardly any extra weight and with no change in the framing system. Um, haven't seen that come out yet, but it's got to be less expensive than
Hmm.
electrochromic by an order of magnitude, and could get you triple pane performance, which of course architects will just use to create more glass area, right? But
Yes. Um, okay.
All right. Uh, so David's question was, so for fenestration, is it still the case that prescriptive compliance is based on NFRC at the rated size, but for C407, you can use the NFRC performance based on the actual size?
correct.
Okay,
In fact, David gets a gold star for understanding that.
But
good
you
job,
would need
David.
to, Dwayne, correct me if I'm wrong, but you would, on the UA calc, to meet the 110%, which would you have to use?
The UA calc would use actual size. We're just using
Right.
the standard size to determine whether the system itself meets our standard.
All right. And this one might take a little, you might want to go back to the condensation, insulation, fenestration,
Mhm.
condensation slides. Can you explain how having more insulation can increase the likelihood of condensation inside? It feels
Mhm.
counterintuitive. Based on that train of thought, a space with 4 inches of insulation will have less a chance than a space with 8 inches of insulation.
Mhm. So what this is all about is where the air barrier, or where the vapor barrier occurs in the wall. And so what the vapor barrier is designed to do is you have, from occupants, from all the people inside the space putting out moisture, you have warm, moist air that's going to hit that outside wall. And basically, outside of the building, you have cold air. Let's just say it's a day where it's 20 degrees outside and you're 70 degrees on the inside. And there's a point within the wall called the dew point where that warm, moist air will actually condense, where it'll hit a surface that's cold and it'll actually condense and turn back into water. Um, and it's pretty complex. It's based on the amount of moisture on the air in the inside, the temperature outside, and the temperature inside. Um, but what happens is that as you add more insulation inside of that the vapor barrier, right? So, if you imagine in this diagram on the right, the vapor barrier is actually just at the back of the mullion. It's the foil face that runs. There's a foil face that runs at the back of that mullion. Um, Basically, as you add more and more insulation behind that vapor barrier on the warm side of the wall, the the amount of heat from the inside of the building that heats that air is less and less effective, and so that dew point moves farther and farther in. Um, and in this condition, this is about 6 inches of mineral fiber insulation. That was enough to make it cool enough that basically you had a risk of condensation on that surface where the vapor barrier was. And so we had to move that vapor barrier farther back. I
So
don't know, Duane, is there a better way to explain this? Yeah, right.
by,
Uh-huh.
by putting more insulation on the inside,
Right.
um, that that framing system is getting colder,
Yep.
and moisture can diffuse through the gypboard and through the bad insulation and other assembly to get all the way down to the face of that framing where the vapor barrier is, and the lesson, if you had no insulation, then that framing would be same temperature as inside, right? But
Yep.
you've got all this insulation that's keeping the heat away from that, and it's making a surface that is more likely to condense. Uh, this is not something that's intuitively obvious when you look at it.
Right. This is why you hire a consultant really to look at this, right? A facade consultant, right? It's complex, right? But it is real, and as you start to add more and more insulation behind your curtain wall, this is something we are seeing. So it's something with the current code, something to be aware of. Um, Watch out if you're putting a lot of insulation behind your spandrel in your curtain wall.
Or let's see, where did I put that? Or look up one of these systems that lets you insulate outside of the framing, in which case your framing will always stay nice and toasty warm, and you
Mhm.
won't have to worry about condensation ever.
Okay, and then Darren had a question about vestibules and um, how effective is a vestibule if the interior door is on a hold open?
Yeah. Um, in fact, if you think about it, when people are coming and going, and Seattleites, we're all so polite. People are holding the door open for each other. So there's large periods of time, especially morning, evening, and lunch hour when lots of people coming and going, and both doors are open at the same time, uh, 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 a lot, which is why the air curtain is kind of an interesting idea. The air curtain uses a certain amount of energy itself, but it does a pretty good job of keeping the outside air out. And and as long along with the outside air, you've got those leaves that blow in, and bugs and other stuff that comes in when you got doors open that doesn't. I guess the downside is that it's going to mess up your nice hairdo as you're coming through the door every time. But but it's a way to look at it. I've worked in Alaska. We used to make a vestibule that was 20 feet long with the door that doesn't open straight ahead, but off to the side at the end of that vestibule, hoping that there was enough time from the time you walked in that the door behind you would close before you went through the other door on the way into the space. So vestibules are a little problematic, and they're better than just having a door that's unprotected, but they get compromised a lot. And like I said earlier, I did a little survey over a couple of downtown buildings one lunch hour and found that it was like 40% of people were using the swing doors instead of the revolving doors. So those get used a lot, and they need a vestibule.
Okie doke. And then back to the building that you did the metal
Hmm.
sort of thing around the window.
Hmm.
Um, Clement says, with the fin instead of recessed glazing for that shadow line, what best practice to use for precipitation intrusion prevention at the top?
Hmm. Yeah, so I mean, typically those fins will just be a snap cap that snaps onto the mullion itself. That's what those fins are that we're showing in that project. So they're just snapping onto the mullion of the window, and then typically you'd lap the air barrier right over the top of the window and seal directly to that. A lot of times we'll use a silicone sheet to do that transition to the window, but the point is that the cap is just an addition. The real waterproofing is happening between the air barrier and the window itself.
Do those just become pigeon habitat, Nick?
You have to design them right. You have to think about birds. You have to think about pigeon habitat. But you just have to make sure the gaps are right. It depends on how far up in the air they are. There's a few different things. How big of a ledge, the angle of the ledge, all will make a difference in terms of whether or not birds will want to sit on them. Whole science. There's a whole science. Whole other consultants you could add to your crew, right?
And those very cool metal spikes that people put on.
Yeah, we love those. Those are our favorite thing.
So cool.
I'd put them in every building if I could.
Vitali says, what table should we use for doing a U value calculation for a for a flat eye joist roof? The tapered insulation above deck is only for drainage, and we will be filling the cavity with mineral wool.
Um, if it's only for drainage, then it means that you're getting really thin at the edges, and you uh, so I'm not even sure that what you're describing it is possible to meet code with, just filling in between metal joists. Um, the amount of heat flow through a roof assembly that has, say, 8 inches of insulation with metal joists versus 24 inches of insulation with metal joists is about the same, because all the heat flows through the metal. And so I I'd be surprised if you could make anything like that meet code.
Vitali just clarified it's wood eye joists. Do you want to put your email back up, Duane?
Well, it's okay. Wood eye joists. That yeah, if you're tapering down to very thin, then the way it works in U values is that the you can't average the R values. You almost all the heat loss is through the thin parts of of uh, of insulation. So if it's tapering down to zero or close to zero, I think you could only take credit for that thinnest area on it.
All right, we have just a couple more things, but I want to note that it's 11:30, and I think that's what we said our stop time was. And I just want people to know, reminder, this is recorded, so if you need to leave, go ahead and go to your other meeting. You can come back and review even the 11:30 stuff's recorded and will be posted to the website. Okay. And Michael is wondering, and you might not have an answer for this, Duane, for buildings that are trying to meet BEPS but are ending up hitting the subalt, what is, and I'm missing a word, so maybe the city, what is the city going to do to help them meet their targets? That might be a Nicole Ballinger or other
Well,
city like answer.
to um, to essentially the obligation is on the building owner, and we're happy to provide technical assistance where we can and advice, but I'm not aware of any substantial program that's available to everybody that would uh, help with the costs of upgrading buildings. It just needs one of the reasons that BEPS was set up the way it is, and other programs have been set up so that there's a very long lead time, and so that people can start working on funding the improvements well in advance. And note that for the state building performance standard and for BEPS, there, if you've got a plan in place that that shows annual progress towards the goal, that's as good as if that plan is approved, that's as good as meeting the target right on. So we're trying to do everything we can to make it easier for building owners, and yet saying, but you still got to do it, and you got to pay for it.
And I don't think I'm speaking out of turn. Rulemaking's not over yet for BEPS, so all of the different things have still haven't been worked out. Um, and then Charlie just had a comment that when you were touching on replacing old curtain wall windows with better ones as a measure to comply with performance standards, that sounded like a good subject for a future lab webinar. And I just wanted to plug that, especially because we've got so many architects and engineers on the call. If you've got buildings that you've implemented any of this stuff that Nick's worked on, or other solutions, get in touch with us if you want to come and teach people about what you did and share ideas. We love that. And then real quick, I'm going to share my screen on our upcoming webinars. Oh, I closed my PowerPoint because it wasn't working. I'm not going to share my screen. I'm not going to keep you for this. Visit up.com to see the upcoming webinars. Duane has the dates for the codes ones noted here. We have a refrigeration next week, commercial refrigeration one. We've got one coming up with commercial heat pump water heater solutions. I think we've got them booked out through almost through April now. They're not all available to register for, but will be. Sign up for our newsletter if you want to get the latest registration updates. And with that, I'm going to thank Duane and Nick for coming. And these are always well attended and it's super appreciated. And we will see Duane next month with Sean Dara, who used to be at the lab. We're getting some applause. Some people found the reaction. Um, and thank you everybody for coming. All right, I'm going to close it out.
Thanks all.
Hi.
Bye.